Hello, my favorite 7th graders. Thank you so much for joining me. We are going to be starting on lesson 15 today. If you're following along at home, it's Saxon Math 87, the 2nd edition. We're on lesson 15 today. So let's take a look at how that's going to go. All right, give me a second to do something about my camera. All right, so there we go. Yay. Getting better every time. All right, guys, today I'm really excited to talk about this lesson because we are going to be reducing fractions. Reducing fractions. Guys, you have to know how to do this because it's going to happen from now until forever. Forever. Algebra 1, Algebra 2, calculus, you're going to need to reduce fractions. Reduce them. So guys, I'm on page 76, like I said, lesson 15, if you wanted to follow along. Let's talk about equivalent fractions. Equivalent fractions. So example number 1 says, find an equivalent fraction for 2/3 that has a denominator of 12. So find an equivalent one that has 2/3 for a denominator of 12. You know what? Give me a second to pause this and fix my camera. Okay. I've just figured out the pause button. It's exciting. So hopefully this will stop like auto recording or trying to autofocus. So, all right. You guys are so patient with me. I appreciate it. Sorry, I'm not technologically advanced. I'm trying. Okay. So so I want to find an equivalent fraction for 2/3 that has a denominator of 12. Okay. Denominator is on the bottom, right? So what do I need to multiply 3 by? To get 12, I gotta multiply it by 4. If I do it on the bottom, gotta do it on the top. An equivalent fraction for 2/3 with a denominator of 12 is 4/12. 4/12. Okay, so let's look at example number 2. It says, find a fraction equivalent to 1/3 that has a denominator of 6. 1/3 that has a denominator of 6. To get, what do I need to multiply 3 by to get 6? 2. What do I do on the bottom? Gotta do that on the top. Beautiful. Next, find a fraction equivalent to 1/2 with a denominator of 6. Need to multiply this guy by 3 to get 6, so I'm going to multiply it by 3 here. So 2/6 and 3/6. Then add those two fractions that we found. We have 2/6 plus 3/6 gives us 5/6. 5/6. Good. Any questions on that? Let me know. But this should be just a review for a lot of you. If it's not, it's a good way to learn. All right, reducing fractions part 1. I need bifocals like an old lady, and I refuse to get them. So switch between glasses and no. Okay, another example of equivalent fractions is going to be on a ruler. And I was debating here. Let's do this. I'm so sorry, guys. We do like the system of inches and feet and all that good stuff. Every other country uses the metric system, and it's so much more intuitive and easy to understand because it's based on 10. Well, unfortunately, ours is based on like 12 inches in a foot, 3 feet in a yard, 5280 feet in a mile, right? Super annoying. But let's take a look at this guy. So what we have is, this is just a normal ruler. It turns out it's bendy and it's totally bent in the wrong direction. This is just a normal ruler, right? In fact, what I'm going to do is maybe lower it a little bit so you can see a little closer. These guys here, so we have between 1 inch and 2 inches, there are 16 little dashes there. 16 little dashes, right? So I'm going to replicate that on my board, okay? So I'm going to do, let's say that this is 1 inch. This is going to be 2 inches. This will be 3 inches. And in between 1, I'm going to have this guy right here. That's 1/2, right? So that's 1 and 1/2. Okay? Then in between each of those, excuse me, now do you see I have 1, 2, 3, 4 chunks? So this is 1 out of 4. This is 1, 2, 3 out of 4, right? So now if we cut this in half again, 1/4 cut in half, right? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 chunks, except in a ruler, in an inch, it's usually divided into 16ths. So we're gonna do 1, 2, 3, 4, 5, 6, 7, 8. Let me make sure I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. So this is my, I'm gonna make my 1/2 real big there so you can see it, okay? Make these guys even bigger. Then I'm gonna make my quarters pretty big. Okay. So you can kind of see how this is nice and evenly broken up, right? Basically remember in the last lesson I said a fraction is just part over whole, right? Part over whole. So we look at this guy and we have 16 whole bits here, right? Well, if I go to this one right here in the smack dab in the middle, 8 is in the middle. So we have 8 out of 16 bits, right? However, it's also reduced down to 1/2, right? Because 8 out of 16 is 1/2. Same with this guy right here. If I were to count, I would be like 1, 2, 3, that's 4, right? 4, so that would be 4 out of 16. Well, 4 out of 16 is the same equivalent fraction of 1 out of 4. So hopefully that makes a little bit more sense, but just know that inches are broken up into 16ths. And you may see this if your parents have tools or if you know somebody who works on cars, you'll see like 3/16 wrench or a bolt that is like 7/16. Weird sizes, right? So, and let's talk about how that works. So if we've got 1/16, 2/16, 3/16, all these break down into smaller ones. 5/16, 6/16. 1/16 is its normal, right? That stays the way it is. 2/16 can break down into 1/8 because if I divide this by 2 and divide this by 2, I get 1/8. 3 out of 16, that's got to stay. 4 out of 16, those are both even, so I can divide them by 2. Now, if I cut them in half, I would get 2/8, but that can be cut in half again, so that's actually 1/4, right? So we don't say 4/16 of an inch, we say 1/4 of an inch. Another time you may see that is especially with in dollars, we have 4 quarters to a dollar. 1 out of 4 quarters, that's 25 cents. 5/16, that stays the way it is. 6/16, sorry about that, it's a little, let's see if I can't lift that up a little bit more. 6/16, those are both even, right? So even numbers can be cut in half. So this could be cut in half and it would be 3/8. So you make your 3/8 of an inch, 3/8 of an inch. Then we have like 7/16, that can't be broken up. 8/16, that's one we talked about earlier. We can cut those in half all the way down until we get to 1/2. 9/16, that can't be broken up. 10/16, those are both evens. So that's 5/8 if I'm cutting those in half. Even numbers, right? You can cut those in half. 11/16, that can't be broken up. 12/16, that one can. We can cut it in half twice. Cut it in half the first time, we get 6/8, making sure I don't mess up here. And cut it in half again, we get 3/4. So 3/4, right? We had 1/4 over here, we got 3/4 over here. 13/16, that can't be broken up. And then we have 14/16. Again, those are both even. Cut them in half, we get 7/8 equals 15/16. We can't do anything with that. Probably shouldn't put an equals there. 16/16, that is 1 whole inch. We have gone the entire distance. So you can see that we have these, all these inches can be broken up based on that, but that we can reduce them down. So that's essentially what today's topic is going to be about, is just reducing fractions. And a ruler and dollars are a good way to, and money, I should say, are a good way to demonstrate that. So with that said, let's see. Oh, let me see if I can get my, sorry guys. Y'all are patient. I appreciate it. Oh. Okay, so with that, that's what I get for moving it for the ruler. Okay, so with all of that said, let's look at the next part. Example number 3 says reduce 18 out of 24. Now guys, there are many different ways, 18 out of 24. There are multiple different ways to reduce fractions. The first thing that we can do is, I'm gonna break up 18 and find my greatest common factor. 1 times 18, 2 times 9, 3 times 6, not 4, not 5, not 6 is already on the board, right? 24, I'm going to break those down. I got 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? And then after 4 comes 5, can't do 5, and after 5 is 6, and that's already there. So the greatest common factor that these guys share is 6, right? So if I divide this by 6 and I divide this by 6, I get 3 up top, and on the bottom I get 4, so 3/4. Now, I think this can be a little bit tedious. I'm gonna be real with you. You're gonna be reducing fractions forever. This is the fastest way that I can think to do it. And guys, if you do not know your multiplication tables, so help me God, learn your multiplication tables, because this is going to be so much harder for you if you do not know your multiplication tables. If you can look at 24 and know everything that goes into 24 to make it 24, you're going to be a lot better off, Here's how I think of it. 18 over 24. I want you to ask yourself, does 2, 3, or 5 go into those numbers? Now, a friendly reminder, in order to find out if 3 or 9 goes into a number, we add them together. 8 plus 1 is 9. Does 3 go into 9? Yes. 3 is also going to go into 18. 4 plus 2 is 6. Does 3 go into 6? Then 3 is also going to go into this number, okay? So that's one way to think of it. 2, ask yourself if it's an even number, just cut it in half, right? And the way I like to do that is like 52, right? Let's cut 52 in half. Half of 50 is 25. Half of 2 is 1. 25 plus 1 is 26. Cutting 52 in half. So you see how it can be pretty easy there, right? And then 5, we know if it ends in a 0 or a 5, bam, we can divide by 5, okay? So looking at this first one, I look at it and I'm like, oh, they're both even. I'm just going to cut them in half. That helps me, right? Get those to a smaller number. That will help. I'm going to lower my desk a little. There we go. Get my act together when I record these. Cut this in half. I get, so cutting in half is just dividing by 2, right? I get 9 over 12. I look at that. I can't cut it in half again, but I look at it and I'm like, oh, wait, no, but I can divide both by 3. Divide by 3, divide by 3. 3 over 4. So originally I could have just divided by the greatest common factor, which is 6. 3 times 2 is 6, right? Or I could just do this method until it gets to a manageable number. You know, I've been doing math for quite a while. This has been working for me. Every once in a while you got to know 7. The only way to know that is to know your multiples of 7. So skip counting. 7, 14, 21, 28, so on and so forth, okay? So let's look at some of these guys over here. We have number 4 says, example number 4 says, this is on page 78 if you're following along, reduce 3 and 8/12 to the lowest terms. Words are hard today, I don't know. Okay, this guy, you don't have to do anything with it. You're just worried about the fraction. I look at that, I'm like, maybe I should write up here, 2, 3, 5, sometimes 7, okay? Both those are even, I'm gonna cut them in half. Cut this in half, I get 4. Cut this in half, I get, oh, I just gave it away, 6. I get 6, well, I can cut those in half again. I get 2 over 3. So the reduced form of 3 and 8/12 is 3 and 2/3. 3 and 2/3, okay? So now let's talk about writing as a mixed number. Mixed numbers have a larger number up in that denominator, or up in that numerator. So example number 5 says 12, this is number 5, I'll write that here. It says 12 over 9, 12 over 9. I want to write that into this is an improper fraction. Let me back up, I think I just said this wrong. This is an improper fraction when the larger number is up top. Mixed number has a whole number and a fraction, okay? And I often do that. I go, oh, mixed number, I mean, oh, improper fraction, every time. I don't know why. How many times does 9 go into 12 without going over? 1 time. We always keep this denominator, okay? 9 times 1 is 9, plus 3 more will give me 12. So 9 times 1 is 9, plus 3 more will give me 12. So I've just converted from an improper fraction to a mixed number. This is improper, mixed number, okay? But looking at that, I ask myself 2, 3, or 5. 2, no, because it's not even, right? 3, yes, I can divide the top and bottom by 3. And if I do that, I get 1 over 3. So dealing with this guy right here, my final answer is 1 and 1/3. 1 and 1/3. Good deal. All right, so number 6, whoops. Example number 6, it's all about fractions today. Simplify 7 over 9 minus 1 over 9. When we're adding and subtracting fractions, we need a common denominator. Fortunately, we have that here. 7 minus 1 is going to give us 6. Oh, now let's ask ourselves 2, 3, or 5. 2, no, because that doesn't go into 2, but 3 does. So let's divide by 3. Divide by 3. We can get 3, oh, let's try that again. We can get 2 over 3. Guys, another way to reduce fractions. Let's say we have, I'm going to go back to that one that was like 18 over 24. So 18 over 24, this is just a different method of doing it. Like I said, there's a bunch of different methods, right? 18, I can break that down into 9 and 2, 3 and 3. Those are prime numbers, right? Can only be multiplied by 1. 24, I can break that down into 4 and 6. This becomes 2 and 2. This becomes 2 and 3. All those are prime numbers, right? So 18 is really 2 times 3 times 3. 2 times 3 times 3. 2 times 3 is 6, times 3 is 18. 24 is 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Okay, if you have something on the top and something on the bottom and we're multiplying, you can cancel those out, like this guy, bye-bye. This one, bye-bye. What I have on the top is 3, and on the bottom I have 2 plus 2, which is 4. So that's a different way of reducing fractions. Either way, however you want to do it, totally fine. Okay. So, number 7 on page 79 says reduce 70% as a fraction. 70% as a fraction. Guys, remember there are 2 percent signs in a, there's 2 dots and a percent sign, so 70%. So in order to write that as a fraction, it is 70 over 100. Oh, let me tell you my favorite part of reducing fractions. If you have a 0 on the end and a 0 on the end, it is dividing by 10. I can divide the top and bottom by 10. Save yourself a step. If you have a 0 and a 0, lob those puppies off. You just lob them off. Gone. What I end up with is 7 over 10. Guys, that doesn't work for any other number, just 10 or just zeros, okay? Don't do that with your 2s or 5s or whatever. And so there we go. We've reduced 70%. Okay, so on page 79, we have the practice A through, whoa, A through T. Go ahead and pause the video. And I want you to do these. Guys, I'm going to check on these too as part of your homework. So make sure that you're doing these as part of your homework, okay? Go ahead and pause the video, do those, come on back, and we'll do them together. All right, so for A, it says form 3 equivalent fractions for 3/4 by multiplying by 5 over 5, 7 over 7, and 3 over 3. Oops, 3/4. 3 over 3. So if we do that, we get 15 over 20. Like I said, if you don't know your multiplication tables, you're going to want to. This is 21 over 28. This is 9 over 12. Those are our equivalent fractions. Equivalent fractions. For B, find an equivalent fraction for 3/4 that has a denominator of 16. Okay? Well, what do I need to multiply 4 by to get 16? Times 4. Times this by 4, we get 12. C, 4 over 5 equals what over 20? What over 20? 5 times 4 gives us 20, and if I do it on the bottom, I got to do it up top. That gives us 16. So the question mark equals 16. And maybe it makes more sense if I write it right over here. So 16 right there. 3 over 8 equals 9 over question mark, right? What do I need to multiply 3 by to get 9? Times 3. Means I got to do it on the bottom, so I get 24. 24 for D. E, find a fraction equivalent to 3/5 that has a denominator of 10. So find a fraction equivalent that has a to 3/5 that has a denominator of 10. Next, find a fraction equivalent to 1/2 with a denominator of 10. All right, so on these guys, I need to multiply 5 by 2 to get 10. If I do it on the bottom, do it on the top, I get 6/10. Down here, multiply by 5, because 2 times 5 gives me 10. And if I do it on the bottom, I have to do it on the top, I get 5. Then subtract the second fraction you found from the first one. So when we're subtracting from, we need to keep it, make sure we got the right order. We're subtracting this from this. That's why this one's first. This is going to give us 1/10. 1/10. All right, let's reduce some fractions to the lowest term. Okay, so I figured using the pause button so you don't have to watch me record or write everything down would be good. So we're going to reduce these fractions, okay? Remember, 2, 3, 5. 2 I can't do here, right? I can do it here, looking at this guy. Cut those in half, I get 4 over 5, right? Cut these guys in half, I get 4 over 8. Oh, I can cut those in half again. 2 over 4. Cut those in half again. I get 1/2. Cut in half as many times as you need. Cut these guys in half. I get 6 over 8. Cut that in half again. I get 3 over 4. Let's come back to this first one. So I can't do 2 for that first one, but I can do 3. If I divide the top and bottom by 3, I get 1 over 2. 1/2. Excellent. Let me pause. I paused so that I can magically rewrite these problems down and you don't have to worry about watching me write it down. Okay, so we're going to reduce these guys by 2. Remember, you don't have to worry about your whole numbers. You're just worrying about the fractions. So we're going to cut these in half and cut that in half. I get 2 over 4. Cut it in half again. I get 1/2. So my final answer is 4 and 1/2. Looking at these, I can't cut those in half, but I can divide by 3. If I divide the top by 3, I get 3 over 4, which means I get 6 and 3/4. 6 and 3/4. On this guy, I can't cut that in half because I can't cut 15 in half, right? The things that go into 8 are 2 and 4, right? Neither of those go into 15, so this is as reduced as it's going to get. Let me just double check it. Yep, I wrote it down correctly, so you're good. So for M, let's cut that in half. We would get 8 over 12. Cut it in half again. We get 4 over 6. Cut it in half again. We get 2 over 3, which means we get 8, our whole number over here, and 2/3. 8 and 2/3. Excellent. That was through M. Now we're going to do adding and subtracting, I believe. So taking a look at M, at M here, we get, N. N, we get 5/12 plus 5/12. On the bottom, that stays the same, 12, right? 5 plus 5 is 10. Oh, we can reduce. We can cut them in half. Cut them in half, we get 5 over 6. 5 over 6. For O, we have 3 and 7/10 minus 1 and 1/10. Guys, I write these up and down like this vertically because I think it's a lot easier to manage. Because now I'm going to deal with just the fraction bits instead of converting it all into a mixed number, or I'm sorry, into an improper fraction. See, I do that. And then converting it all back, blah, can't be bothered. I'm going to leave it like this. I'm going to deal with just the fraction bits first, which means it's going to be a 10 because we've got that common denominator. 7 minus 1 is 6. 3 minus 1 is 2. I can cut these guys in half right here. That's going to be 3 over 5. So my answer is 2 and 3/5. 2 and 3/5. All right, for P, we are going to talk about cross-canceling if we have not already. 5 over 8 times 2 over 3. Guys, 8 breaks down to be 2 times 4, doesn't it? So really what this whole problem is saying, on top I have 5 times 2, 5 times 2. On the bottom I have 2 times 4 times 3. 2 times 4 times 3. Can I cancel anything out? Absolutely. This and this, right? 4 breaks down into 2 times 2, but there's no other 2's up top, so there's no point in me breaking it down. So what I'm going to do is keep that 5 up top, and on the bottom I'm going to have 12, 5/12. Awesome. All right, so for Q, write each percent as a fraction. Guys, there are 2 dots in a percent sign. 1, 2, which means we're going to take 90 and we're going to put it over our 2 zeros. Just like this, lob them off. 9 over 10. It's that easy, that easy. That was QR, 75%. There are 2 dots in a percent sign, so we are going to put that over 2 zeros. So just like this. Oh, finally, we've got one. 2, 3, and 5, these don't go into it, right? Because 1 plus 0 plus 0 is 1. 3 does not go into 1, so 3 is not going to go into this. However, they both end in a 5 and a 0. We can divide by 5, right? Divide by 5, divide by 5. So we have 75 divided by 5, goes in 1 time, 5. 25, that goes in 5, right? So we have 15 over and 5. Think if you have $1 and you have, you cut it into fifths, you're gonna have 20 nickels, right? 20 nickels. Oh, well, looks like we can do that again, right? Divide by 5, divide by 5. That gives us 3 over 4. So 75% is written as 3/4. And if you think about that, 75% is 75% means cents, right? So 75% is the same as 0.75, which is if you had 3/4, you'd have 75 cents, right? 3/4 out of 4 that make $1. That's where I'm getting that from. All right, so for number 8, not 8, I'm sorry, that's S. 5%, 5%. Guys, if we do this over 100, now we have a 0 and a 5. We can divide by 5. Divide by 5 up top, divide by 5 on the bottom. We get 1 over, and 100 divided by 5 gives us 20. If you think about it, 10 divided by 5 is 2, so 100 divided by 5 is 20, 2 with a 0. All right, so for T, it says, find a fraction equivalent to 2/3 that has a denominator of 6. 2/3 that has a denominator of 6. I need to multiply this by 2, which means I need to do it upstairs as well and get 4/6. Subtract 1/6 from this guy and reduce the answer. So we're going to subtract 1/6 from this guy, and we get our denominator remains the same, and 4 minus 1 is 3. Guys, we can divide both those by 3 if we do that. We get 1/2, 1/2. It's a good idea to recognize when we have a 1/2, right? If I have 12 out of 24, that's a half, right? So we can just reduce it straight away to 1/2. If I have 50 out of 100, that's half, so we can reduce it straight away to 1/2. Just keep an eye on things that are easy, like, right? Make your life easy. All right, guys, I think that's it for the practice problems. If you have any questions, let me know. Otherwise, enjoy your homework, and I'll see you guys in class.